we are going to learn about the SLAM. So the SLAM is the backbone of robotics and autonomous vehicle navigation. All right, welcome you again. So what is SLAM actually? So what's the meaning of the SLAM? So SLAM means like we are like getting a map of unknown environment. So these words are really important about the unknown environment and while simultaneously tracking the position of the agent within that environment. So what is the agent? So agent can be a autonomous vehicle or a robot. So that's the context in our presentation today. So the meaning of that will be building a map of unknown environment while simultaneously tracking the position of the agent within that environment. So this has dual process. So that is the localization and mapping. So this will be essential for the autonomous systems to navigate, especially the navigation, and can occur this in real time or after the data collection. So I will explain these two words in the upcoming slides. All right, so I think you have a better idea what the SLAM means. So we can move on. So how's the evolution of the SLAM? So evolution can be like started from 1986 actually. It started with the filter-based methods. EKF means extended Kalman filter. So filter-based methods will be there as evolution started. And in after that, we have started the algorithmic stage. So it basically graph-based optimization. As you can see in this one, the probability things will be happening there. Yes. And after that, we'll be having the perception stage. So now in the world, they are looking forward with the deep learning and semantic understanding. So that's the evolution of the SLAM, and it will be continuously improving side in the robotics and autonomous vehicles. Yes. So let me introduce you what's the need of the SLAM. So imagine this picture. So you have a room and you don't know about the environment of that. So without the SLAM, when we clean in that room with these robots, think about this as a robot, and he is moving like everywhere without a plan. All right. So if we have the SLAM, he can like control the cleaning process in a correct way. So that's how we have to done in this cleaning process. For that, we need the SLAM. So I think everyone here understand the need of the SLAM right now in a similar simple way. All right. Then let me go through the framework of this one. So how can be the SLAM integrated in there? So we will have the sensor data. Sensor data can be come from the camera as well as the LiDARs and some other sensors as well. So in the autonomous vehicle, we have a GNSS sensors as well, and IMU data will be there. And we will like in a basic way, we will have a front end as well as the back end. All right. So in the SLAM, the front end is a sensor dependent one. It means the sensors will play a major role in that part. And we will have a independent processing as well, sensor independent process. So that will be the backend process. Yes. So regarding the sensor dependent process, so we will have the front end and it will have some more features like feature extraction, data association like feature tracking, loop closure will be there. All right. So regarding the backend, we will have the map estimation. So like this one is the final product that we are going to make. Yes. Regarding the map estimation, we will have the graph optimization methods, especially in there. And those things are combined in the recent research, like post graph, factor graph will be there. So these things are heavily in the maths area. So we have to use some of the methods, like we have to get a knowledge about the maths concept as well. Yes. So this is the estimated trajectory and the map will be there. So the map will be there. So we can easily navigate across this one. So in this one, like front end provides a real-time camera pose estimation, while backend provides the map updates and optimization. So optimization part will be done by the backend. Yes. So recognizing a loop in a SLAM algorithm can correct cumulative errors. So this this feedback loop will be the main thing that happening in there. So it will correct the errors so that we can get the robot position and update map to improve the accuracy. So that's the main process in the SLAM that we are going to learn about today. So we will have a front end and a back end. Those things will be there. Yes. So what are the sensors that we are using in the SLAM? So basically there are cameras. So these three cameras is already up to a certain research level, and nowadays this camera will be used for the research in every situation. So there will be having a monocular camera as well as stereo camera and RGBD depth cameras. So in that one, we will have advantages as well as the disadvantages. For the like, it depends on the application. If we have a like application that needs a RGBD camera, we have to use that one. So regarding the event cameras, so we will have a like a advantage like low delay and high dynamic range and no motion blur. So and a very low power consumption will be there. So like in this one, we will have a disadvantage. A single event has little effective information and sparse, incomplete data as well. So that's the research area that currently going on. And with the LiDAR, we will have a 2D LiDAR and 3D LiDAR, depends on the application. We can choose those things. And in the 2D LiDAR, we will have a 2D point cloud map. And 3D LiDAR, we will have a 3D cloud map. And when we, as mentioned in the framework, we have to input data to get a output with the map and the trajectory. So we will provide the IMU data, odometer data, and 2D LiDAR data in the 2D map. So there are companies as well who build in the LiDARs in there, and there are 3D foreign manufacturers and domestic manufacturers are also there. This is from a research paper. Yes. And regarding the IMU, initial measurement unit, we will have three units like XYZ coordinates systems, and the radars will be used. But basically, in the recent research, we will have these kind of a camera and lidar fusion will be there. So yes, so we will have the sensors, and we know the framework right now, and what are the applications from this lab. So when we talked about the applications in the autonomous driving, we will have the high definition map generation and update. So it really needs for the like generating high HD maps to get high quality data from those things. So we can create accurate 3D maps from there. Like so when we are generating the map, we need the small map generation as well. Like a small area, we will need a parking lot or where the load speed enables. So we need like a good method to map that area. So we are using SLAM for that as well. Yes. So when we have the map, we have to localize it within the existing map. So that for that as well, we are using the SLAM. Yes. So now when we are moving on to the robotics, we will have the autonomous mobile robots as well. So like in the robots like warehouse robots, cleaning robots, and delivery robots, there can be used of the dynamic. So in the dynamic environment, so I will explain in the last slide of this one, like what's the dynamic environments in there. So we will use the SLAM to navigate and like in there. So in the robotic manipulations like robotic arms and mobile manipulation robots, so we need to interact with the objects. So there could be in this picture as well, we need the SLAM to map and interact with the objects. So regarding the this one is really important. This one is really important one in the latest research. So autonomous exploration for inspection, search, and rescue. So those are the things that currently world moving on. It basically like underwater exploration to see some in there. So we will use the drones, ground robots to utilize SLAM to autonomously explore and known hazardous environments. So basically in the underwater, we will use the SLAM in there. So currently in the space as well, we are using the SLAM. Yes. Then, so what are the SLAM algorithms that currently in the world? As I explained in the earlier slides, so we will have the filter-based SLAM. So it basically estimating the robot poses and landmark position probabilistically. So we will use the probability to like estimate the robot poses and landmark positions. So the famous one is EKF SLAM, extended Kalman filter SLAM, and fast SLAM will be there. So there are so much of examples, but I choose only two of them. Yes, regarding the optimization base SLAM. So we will have the optimization base SLAM as our second SLAM algorithm. So we will use the graph optimization problem. So optimization, some kind of a module that we can take on the university as well, like reducing the errors in the loop closure. Like there we will be having the graph optimization problem. We will get the minimize error path to do that. And we will have the graph SLAM, iSLAM2, and SLAM++ will be there. Like there are a lot of SLAM algorithms. Just three of them will be listed here. Yes. Moving on to the deep learning SLAM, like it incorporates with AI for better perception and feature extraction. So we will use the CNN. CNN means the convolutional neural network. So there could be a SLAM with that. And deep visual odometry SLAM will be there. So there are several SLAM objects, like this one is really, really famous in the world as well. Deep learning SLAM. Yes. Now moving on to the online and offline SLAM. So as I explained in the first slide, let's go to the first slide. So I explained about the real time or after data collection. So it can be occur in the real time or after data collection. Yes. Now we are moving on to the online and offline SLAM. So in the online method, so there can be online and offline, but in the subcategories, there might be sensor fusion and deep learning things will be there. So focuses on the current pose of the agent and updates the map incrementally as new data received. So this is really important. So this will be focuses on the current pose. All right. So and updates the map incrementally as new data is received. Yes. So moving on to the offline method, we will have the process to collect all data after a mission is to complete and optimize the entire trajectory and the map. So we will collect the data and after the mission, like to complete the optimized entire map and trajectory. So as I explained earlier about the LiDARs and cameras, we will have the sensors and fusion method of the SLAM. So we will combine cameras and LiDARs together to uh, to get a good map and localization as well. So regarding the sensor computing technology, yes, open SLAM based or filter based. So those are combined together to get a good output. This also like a modern way that we are going to do with the SLAM. So this SLAM is like a developing area, so you can research on that as well. So today regarding SLAM, so we learn about several SLAM. So I want to give you a brief overview about the Wildcat SLAM. So this is introduced by the CSIR of Australia. Uh, Yes. So when we explaining about the Wildcat SLAM, first things like we have to learn about the odometry. What's the odometry and post-graph optimization? So regarding the odometry, we will have the robot's position and motion over the time with the sensor data, as well as you can use the LiDAR or camera, those things, and increment to track the incremental movements for accurate localization and mapping. So that's basically the meaning of the odometry. So we will have the robot position and motion and sensor data to track the incremental movement. So that's basically the odometry. So regarding the post graph optimization, like we will have the robot poses like represented as nodes. All right, it's like a node, and nodes are in the graph. All right, so we will have the graph, and we will have the constraint as well. All right. So better to like learn about the optimization modules in your like university, so you can get a good understanding about those problems, optimization problems. And regarding the constraint as well, like we will have some constraint, like here we will have like a object here. So we are here. So those are the constraint like that. And we have to optimize to minimize the error to achieve consistent mapping and localization. Like this theory will work on like that. Hope you have a good idea about those two words. Now we will move on to the Wildcat Slam. Like what's the overview of that? Yes, Wildcat Slam, like they are using the IMU and LiDAR data, and LiDAR initial odometry and local mapping will be there. So we will have the like sub maps. All right. So we have a map, and we will have a sub map as well. Like sub maps will be there. Like in the probability as well, we learn about those things. And like we will have the like continuous estimation on the robot trajectory and produce submaps for the post graph optimization. So the submaps will be going into the post graph optimization. So we learn about the post graph optimization in a brief way. Yeah, like if you are interested, you can learn on the YouTube and other links. So where the submaps used to generate the odometry edges as well as the loop closures to efficiently map in the large scale environment while correcting the odometry drift. So this one is really important. Odometry drift will be like correcting synchronously, like it will be corrected on time. All right. Yes. So this is also a online SLAM method. So as I explained about the online and offline SLAM, so this is online one. And the research paper link also listed here, you can visit on later. So this one is the latest one, like we have studied about the Leo SAM and Fast Leo 2 previously. And now we will have the Wildcat. It will showing a good results in here as well. Like, yes, so that's the overview of that Wildcat Slam. So regarding the Slam overview, like we will have challenges and future. So regarding as I explained in the drift as well, we will have errors over the time. And we will have the dynamic environments as well, like in the autonomous vehicles, we will have like pedestrians walking here and there. So that could be dynamic environment. So the event cameras play a like a important role in there. So search about the event cameras and in the YouTube as well. Okay, real-time process will be another challenge, balancing accuracy and computational constraints. So if we have to use high computational power, it will be not necessary, and the sensor limitations will be there. Yes. So regarding the future of the SLAM, I like to introduce you like multi-sensor fusion will be one will be a hot topic in the future, and the SLAM in the extreme environment also play a role. All right. So yes, that's it. Thank you. So if you have any question, like let me know.